Ok. Bom dia a todos e bem-vindos a este último webinar do projeto Re.Data, os lentes webinars, e esta série de 13 webinars que começou os dois, na terça-feira. Este último dedicado à ferramenta Amnesia, né? O tópico global destes lentes webinars é sobre o essencial da proteção de dados em projetos de investigação. Portanto, há alguns conselhos e há algumas regras de boa etiqueta e, ao nível destas sessões online. Pronto, pedimos que usem o chat e a área do Q&A para deixarem as vossas questões, ou então levantem a mão e no final da sessão vamos ter uns momentos dedicados para questões mais dirigidas ao orador de hoje. E as apresentações e as gravações serão disponibilizadas no final da sessão. Vou tentar andar aqui um bocadinho entre o inglês e o português, porque o nosso orador é grego, mas vai fazer a sua apresentação em inglês. A sessão 2, pronto, como disse, é feita pelo Manolis Terrovitisio, que vou apresentá-lo. Pronto, é um investigador um, no Instituto de Sistemas de Gestão de Informação no Athena Research Center. O seu trabalho de investigação inclui a análise de grandes volumes de dados, a Big Data, a privacidade de dados e métodos de anonimização. É responsável pelo desenvolvimento do software Amnesia no mesmo centro de investigação e tem estado envolvido em vários projetos de investigação financiados a nível nacional e pela União Europeia. Trabalhou como consultor nos setores público e privado na concepção e otimização do desempenho de sistemas de informação e trabalha como responsável pela proteção de dados na Rede Nacional de Medicina de Precisão em Cardiologia e Oncologia. Além disso, pronto, também tem uma vasta experiência na aplicação dos princípios de privacidade, desde a concepção nos próprios ecossistemas de informação. Agora passando um bocadinho para inglês, I'm Manolis, e não sei se temos aqui alguém em inglês também. Manolis will do the presentation of this anonymization tool software, which is one of the main responsible person for its development, and is going to present the tool and is going also to do a short demo for you all to be more acquainted with the tool. Now in português, sobre o projeto Re.Data, julgo que a maior parte de vocês também já conhece. Este projeto que está praticamente a finalizar e hoje está a decorrer o último workshop online, porque devido à greve, este workshop teve de ser transferido para uma sessão online e o workshop que aconteceria amanhã foi cancelado, uma vez que existe a forte probabilidade de prolongamento de greve para o dia da manhã. O projeto Re.Data para já tem atingido bons números ao nível de todos os materiais e entregáveis que tinham previstos para serem entregues. Aconselho-vos, para quem não conhece, para visitar o website Re.DataPT. Foram desenvolvidas ao longo do ano uma série de formações, de capacitação de profissionais para a curadoria e gestão de dados de investigação, de capacitação e sensibilização para todos os conteúdos relacionados com a gestão de dados de investigação para os próprios investigadores, e também houve aqui momentos de formação e de capacitação de formadores para a ciência aberta e de potenciais formadores de data stewards. Com tudo isto foi desenvolvido um hub com recursos e competências para a comunidade. Deu-se aqui também o pontapé de saída da rede portuguesa de Data Stewards, que também poderão, para os interessados, ingressar, visitem o site, e depois também, entretanto, também colocarei aqui os links de acesso. E também temos, e também tenho uma série de recursos que poderão, que eu também já partilharei aqui convosco no chat para que possam ficar com a informação do vosso lado. Portanto, aqui uma imagem ou imagens, não é? Valem mais que 1000 palavras. Isto é, não é um pouco o reflexo do trabalho que foi desenvolvido ao longo deste ano no contexto do projeto Re.Data. Alguns números, não é? Muitos deles ainda estão a ser concluídos, como os webinários, os workshops, os 2 MOOCs que estão planeados para ser desenvolvidos e para já temos tido uma aceitação muito grande por parte da comunidade, porque se pretende aqui dar também, de alguma forma, o pontapé de saída para a criação desta rede de gestão de dados de investigação. Acompanhem a nossa atividade, pronto, tem aqui o acesso mesmo às redes sociais, ao Blue Sky e ao LinkedIn principalmente, e o canal do YouTube onde esta gravação também ficará disponível, e depois também receberão a apresentação e o link para a própria gravação, juntamente com o certificado que também será emitido, e que será enviado, durante a próxima semana. Ok, e agora passo. I give the floor to Manolis. Thanks once again for being here, for accepting our invitation. For me, it's a pleasure to see you again, and the floor is yours. If you need anything, I will be here. Just, I'm going to put my camera off, but I'm going to share some links as you are going to talk, to share the links from Amnesia, and if you need anything. Thank you so much.
Thank you very much, Paula. I'm very happy to see you again, and I would like to thank you and Clara for the invitation. I'm very happy here to present the tool because, I want to see it being applied to practice and receive feedback. So I understood from the Portuguese they already gave an introduction. I'm Manolis Terrovitisio. I'm a computer scientist, a researcher, director of research in Athena Research Center, which is a public research center in Athens, Greece. What I will do today is I will provide an introduction that explains what anonymization is, when it should be used, and also briefly explain some techniques for applying anonymization. So this background will allow you to understand how to use the tool, because it needs some understanding of what you're doing. And then I'm going to have a demo on using the tool to anonymize some artificial data that we have. And I think it's the same data that you can find in the website, and try it yourselves. So I will start right away with sharing my presentation. Okay, I understand that.
Yes, all good. Just need to put in presentation mode.
Yeah, it's a lot of us. I think questions, you'll write them or ask them at the end, because I won't be seeing hands to stop the presentation.
Yeah, no worries.
So we can discuss everything at the end. So what I will be presenting is Amnesia. Later, this is the tool that we have created for data anonymization. It's an open source, free to use tool for any purpose, from academic to commercial, and you can download it from OpenAIR site. This tool is created by Athena Research Center, and it is OpenAIR that gives it as a service to the community. Now, I will get a bit to the background to get some context. I understand that everyone is aware of the GDPR, the General Directive for Protection of Private Data. So this is a regulatory framework that provides important protection, clears in a significant manner the landscape of what you can do and you cannot do with the data. And in a way, it puts some severe limitations to the data that we might have access and want to use for research. So what the GDPR says more or less is that you need to have consent, you need to have collected the minimum data required. It has some ways to allow to the one who collects the data for operating purposes to conduct research on them, but then this is limited, it cannot be exchanged with universities and so on. So doing research on private data requires a significant administrative overhead. So a solution to this is to extract anonymized data from the private data, because what we do usually in research is we're not, okay, in some cases we might be interested in individuals, especially in medical, maybe they want to, in health sciences, they want to contact the patient, but mostly what we do is extract statistical properties and create models, either traditional models or, now with machine learning and AI models. And the idea is that what we need is statistical knowledge and not personal identification. So what anonymization tries to do is to transform the data from personal data to anonymous data that preserve as much as possible the statistical properties of the original data without having identifying information. To make things clear, when we apply anonymization to data, in the GDPR sense, anonymization, then the resulting data have undergone an irreversible data transformation. You cannot go back to the original data. They're different. You have lost some information. You cannot really anonymize the data and the data being identical to the original one. And the main benefit is that anonymized data are not considered personal data anymore. And this means that GDPR does not apply on them. It's statistical data, and you can do with them as you choose. A misconception here on a technical level is on the difference between pseudonymization and anonymization. I guess before GDPR, we didn't make this distinction formal, or if we remove the names, we just call the data anonymized. But it is not so. Pseudonymization is the process of replacing direct identifiers. I'm talking on a technical level, replacing direct identifiers on data, deleting the name, the social security numbers, or any other number that directly identifies a person, putting there some pseudonym, or even without putting a pseudonym, it can be implied from other data. And this data that has been redacted in this way is protected to a sense. It's a good measure to enhance protection. But unless we have some kind of guarantee that what we did is reversible, then this data is still considered personal data and cannot be used outside the limitations of GDPR. Okay, there are some cases that even if it is reversible, but the recipient of the data cannot reverse the data, they can still be considered anonymous. But this is a detail I'm mentioning here to someone who might be interested. We're not going to go in depth. I'm going to explain a bit more on the technical level what's the difference and what we try to do with anonymization. But let's have clear why we anonymize data. We anonymize data because the resulting data is outside the scope of GDPR. To be certain that data anonymized, we need a statistical guarantee that this is not going to be reversed. No one will be able, with high probability, to understand the original data or to identify the original persons behind the data or attribute properties to them with high confidence. And it's actually a technical safe way to share data that's needed for research. So this is a very common scenario for anonymization. You're a practitioner, let's say that you're a doctor and you have your patient data, and then you want to share some information with a university that's doing research. You can anonymize the data and share the anonymized statistical data with the university to do their analysis, do their ML or statistical models. So it's sharing when you don't have consent. It's sharing when you don't fully trust the recipient, right? You want to give data to someone, but let's say you cannot bind them legally, or you just want to give them open on the internet, so you don't know who is using them. Anonymization will provide a statistical guarantee that they will not be able to reverse this transformation and understand personal information. And also, a final requirement is that reduction in data quality is acceptable, right? This does not happen in all cases. When you anonymize, you are going to lose some accuracy on the data, some accuracy on the statistical properties. So the analysis must be tolerant to that. Now, let's go back to understand the difference between pseudonymization and anonymization, because this is crucial for understanding both the dangers to hastily anonymized or pseudonymized data, and also the challenges of anonymizing real data. This is a real-world example that came from one of the first papers around year 2000 on data anonymization methods. So in Massachusetts, in United States, they had this law about forcing hospitals to provide anonymized information about treatment. I would put anonymized in brackets because it was anonymized in the terminology of the era and not in GDPR sense. So what they basically did is they removed the names, they removed the social security number, and they published the data that you can see on the left cycle here, the medical data. Also in the United States, they have this thing about the voters catalog that is public, and they have your name and they have some personal data. And between these two public data sets, the anonymous in the terminology of the area medical data and the eponymous data of the voter list, they had three fields in common, which was the zip code, the birth date, and sex for the gender of each person. Now, it was this combination of three fields create a unique combination for, I think, 90% of the population. So it was very easy to join this data, the ones with the names and the medical ones, and really attach a name to its medical record. And this could easily happen online. Just as a comment, in year 2000, the web is there for 5-10 years. We just have our first online sources. These dangers were not that evident or so important when we had everything on paper in the 80s and before. So as data came online, and now that everything is digital, it's very easy to do this kind of joins and find these big databases. So these dangers were not evident. But basically, the danger of having pseudonymized data, just removing information without paying attention of how other secondary information can be used identifying a person, has come up in the last few decades. And we call these data that are descriptive, but they can be used to the identification of a person as quasi-identifiers. They're not direct identifiers, it's not your name, but your zip code together with your date of birth can lead in identification of a person. So one of the first guarantees that we're going to see later in Amnesia, and it's an intuitive one, was k-anonymity. The idea here is an intuitive idea on how we hide someone. How we hide is that we make the information of one person indistinguishable from the information about another group of persons. Right? A person is lost through a vast number of other persons, like we believe that anonymity works in society. But think, for example, that we have, assume that we have the data on the left side, which is a pseudonymized version of a very simplified medical record. So you have the zip code of, there are no names or direct identifiers, it's just an arbitrary identifier. And we have the zip code of a person, their age, and their nationality. Now, even just by knowing the age of a person, if you know that a person is 20 years old and it's on this database, you can directly identify the first record as their record, right? You know the zip code, you know the nationality, and basically you know they're suffering from heart disease. So this quasi-identifier, the descriptive information, the zip code, the age, and the nationality can be used to identify a person. Now, what we do for creating a k-anonymous version of this data is to reduce the accuracy of the information so that each person shares the same descriptive information with other 3 persons. So we create groups of at least size 4, which is what you see on the right side, which is a 4 anonymous version of this data set. What we have done here is made certain that if you know anything about a person, there will be, with respect to the zip code, age, and nationality, you will have 4 persons at least that share this exact information. And to this end, we have completely removed the nationality information. Instead of reporting the actual age, we're reporting age categories, less than 40, 30 to 40, and more than older than 40. And for zip code, we have removed the least important bits. The zip code in all countries is a kind of structured information where the rightmost bits show the most refined administrative area where someone lives, and then as you go to left, they usually represent a broader administrative area. So the anonymized version of the data is now on the right side, and the cost we have paid for this is that we no longer have accurate information on the zip code and on age, and we have lost completely the information nationality. But we can provide a statistical guarantee that if you know something about the person, you won't be able to identify the exact record on the published data. Now, I want to get a bit into detail on how we do this information, how we generalize the quasi-identifiers, because it is something that the user has to do in Amnesia. The idea is simple. We replace the values that are refined and they provide a great level of detail with values that are more generic and they provide less level for detail. In geographical areas, for example, this is quite simple. This is a very simplified example. Instead of if you have the country where a person is born and this identifying, you can just report a broader area of South and North Europe. And if this is still identifying, and identifying when you're using the k-anonymity framework means that there are less than k persons that share this property, you can replace this broader region with an even broader one and just say that someone was born in Europe. So what the user has here to do, maybe semi-automatically, is create these levels of generalization because these need some semantic information. They're related to the analysis, to what the data mean, and you have to instruct the anonymization tool on how you want the steps that it has to take to reduce the accuracy of the information so that the information still remains useful for analysis. So you have to create this tree, and what the algorithm will do will start from the more detailed level and see if this is enough to guarantee anonymity, and if it's not, it will start go up. I'm not going to get into these details, but I'm going to explain a bit of how Amnesia can help you create these hierarchies, because this is something that we're going to see and use later in the demo. So imagine that we have the age attribute, right, which is simple, and you want to create a hierarchy for the age of a person. Now, what Amnesia will do is it will read you will load the data set, it will read the data set, and it will tell you that in the data set we have ages, from 1 to 84. Right, and age is basically an attribute where you can have a lower and upper bound easily, because unfortunately our time is limited in a way. So when you have a continuous domain, because here is numbers, the first thing, if you want Amnesia to create a hierarchy of you, the first thing that you are going to tell Amnesia is how to create ranges, how to cut the whole domain in ranges. So you just give a number. You say, I want you to split the whole domain in 5-year categories. So persons age from 1 to 5, infants will be in one category, that's 0 to 5. Persons 6 to 10 will be in another category, 6 to 10, and so on. Now, after creating this first level of, let's say, more generic representation of the ages, then you need to tell Amnesia how to keep creating more generic representations, so we will be certain that the solution will be found. So this is providing another parameter, which is the fan out of the hierarchy tree, which is basically how many children each node will have in this hierarchy tree. So in this example, the fan out is 2, so it will split the domain in 5-year periods and then start combining. This will create the first level of nodes, and then it will start combining every 2 nodes to one of higher levels. So in the first level, you have 5-year periods, in the second level, 10-year periods, in the third level, 20-year periods, and so on, till you have one node representing the whole domain. And now a generalization hierarchy has been created that makes sense in a way and can be used for anonymizing data. I think in the interest of time, I will not go to other capabilities of Amnesia like the KM anonymity. I will just tell you that this method that we did works well for very traditional data where you have a table and a few attributes describing a person. If you have more sparse data like transaction logs for medical cards, the whole medical history that's, let's say, tens of diagnoses in your past, then you cannot expect that all records will be the same. So a weaker form of privacy guarantee that works on more sparse data is KM anonymity, that requires that every combination of M descriptive attributes and information about the person appears K times. So I had here an example of bills for a supermarket, and I'm showing that in an anonymized version, if anyone knows 2 products that you bought from a supermarket, there will be at least K customers that have bought the same data. I will not go into more details on this. Just know that there are more capabilities for more complex data that actually do come in practice. Okay, and a bit about Amnesia. Some of its benefits. From the beginning, our focus on Amnesia was to make it user-friendly. There are a lot more privacy guarantees, stricter measures to take on the protection of data, but from our understanding of what's happening at the moment is that data anonymization methods are not extensively used yet because they're hard to apply and it's not easy to decide on their parameters. And of course, in several cases, they reduce the data quality, so this is unacceptable from some types of analysis. So our focus in Amnesia is to make it as user-friendly as possible. And if you meet any problems, if you have any ideas or something gives you trouble, please feel free to contact the help desk and let us know. It's an isolated application. It works locally. You download it and you don't need connection to the internet to work, so you don't transfer data outside your own premises, which is an important security measure. We have an online version that you can use, for demo, for some kind of experimenting with non-sensitive data. But if you want really to do some work, you download it and work locally, and no one gets a copy or access to your own data. It is set up as a different, client-server architecture, but the server runs on your own premise and the client connects to this server. So if you don't have connection to the internet, it still works. We try to give a lot of automizations and visualizations that help you understand what you're doing and what the result will be and the impact on data. We have these extra features of game anonymity that I briefly presented that allows you to support high-dimensional data, which unfortunately come in practice more often than we believe. And finally, because we have decoupled the interface from the anonymization engine, if you're a developer, you can just take the anonymization engine and plug it into your own information system, so you can automate some tasks or do the anonymization through your own customization and interface. Now, this is a bit of old data, but it's there for quite a few years. We have, I think now it's 150,000 visitors or so on, 10K downloads and more. So a lot of people have used it or tested it or explored it. We have reduced bugs. It's quite robust. And of course, we're on track to developing more features. Okay, I will only talk about one upcoming feature because we're going to release it probably next week, and it's quite helpful, especially in the health domain. We saw previously that we anonymize data that are in tables, but in practice, identifying data come in several different different formats. A common problem is when someone is sharing medical media and imaging. The most common data file and standard is DICOM. DICOM actually has the media and it has then a lot of metadata. And when we meet a lot, it can have up to 5,000 different tags. So in this metadata, you can have identifying information from direct identifiers, the name of a patient, the name of a doctor, and so on, to let's say more quasi-identifiers, the hospital, the date, and descriptive information about the patient. So what Amnesia will be is already doing in some version, but it will have the full capabilities on the upcoming 1.4 version, is it will be able to read the whole metadata, present them to the user, help the user create anonymization or pseudonymization solution. And then what's crucial for such complicated data is that you can save a template for anonymizing or pseudonymizing them and reuse on future anonymization efforts on DICOM data, which actually believe it's going to save a lot of time because the first time you try to anonymize something that can have hundreds of tags, it will take some time. So when we save your previous effort, it will really speed up how you anonymize DICOM media in the future. we plan also to, in the future, to have some support for differential privacy, but I'm not going to talk to that. I will go to the demo. Yeah, I will just reiterate some limitations of anonymization that I've already said. Anonymized data lose some accuracy on the information, so this has to be acceptable in the analysis. There are some gray boundaries between what is anonymized and what is pseudonymized. This is recognized also in, let's say, the documents in the preparation of GDPR. Anonymization always carries a risk, and up till now it is quite open how do we use what's the correct the best privacy guarantee to use, and what's the best parameters. These are kind of open questions that need answering from experience, and it's not just technical questions. And a difficulty that we're trying to address in Amnesia, it is that it is a complicated process and it cannot be easily fully automated. So yeah, that's it on the presentation. I think I gave you some background on what Amnesia will do, and now I can go directly and show you how Amnesia does that. Paula, I think I should do the Amnesia demo and have all questions at the end.
Yeah, or just we have here one, I think you could answer. It regards the operational system where this your software of Amnesia works on. So
Okay.
for Mac operation system is not possible. Only
is
for
not
Windows and Linux, is that it?
Yes, it's Windows and Linux, but we're receiving a lot of requests about Mac lately. So we're thinking of it, see how easy it will be to support one more version in the future, and maybe we'll release a Mac one sometime in 2026. The problem is, if you make one change, if you support 3 versions, it's quite a lot of hassle. And in the beginning, we had in mind that for big data sets, you need important computational power, so most servers are Windows or Linux to do performance.
Okay, thank you. You can do your demo now. Thank you.
Okay, I will go to first page, set actually. Well, the first thing you have to do is upload the data to Amnesia. As I said before, Amnesia runs locally, and I'm using a local version, so everything is on my computer. Even if I didn't have connection to the internet, everything would work. So I'm going to use data from my local disk, but if you have trusted repositories in Zenodo in some kind of Dataverse server, you can use them directly. So I uploaded a file, which is a CSV file that's delimited by the semicolon. I'm sorry. Yeah, it was in Greek, so it didn't work. So this is a CSV file. It's a common format, easy to export from almost any data management tool, from Excel, from databases, from everything. So I'm telling Amnesia that my data is separated by the semicolons. Amnesia loads the data and it tries to guess the type of data, but this is just a guess. Right? It reads the first lines and it tells you, I think this is a string, this is an integer, and so on. Now, in this example, it has guessed the types correctly. So the first decision I have to make is which data I'm going to have on the final anonymized data, which attributes I will have in the anonymized data set and which I will not. And obviously here, I will not include this is data, this is simplified synthetic data from UK, representing UK medical records. So they have an identifying number on the UK health system, and they have the name of a person. So obviously these 2 attributes have to go, right? I'm not going to have them in the final data because they will, the direct identifiers, there's no point in anonymizing them. Also here I'm going to remove I will leave the date of birth and see few anonymization examples. So the data has been loaded and the type has been decided. If I want to do pseudonymization with some masking, there are masking abilities, but we're going to see the anonymization ones now. So what I have to do is for quasi-identifiers, I have to create an anonymization hierarchy like the one I presented previously in my presentation. If I have created one in the past or someone has shared one with me, I can load it and I will actually use such an predefined hierarchy for the marital status. Now, because this represented real data and marital status was an open question, responses are, whatever anyone wrote. Someone wrote no in marital status, others gave more information, not just single but divorce and so on. So this hierarchy has been created, which groups semantically related responses data to categories which make sense. So it's single and married here. Now, let's assume that the quasi-identifiers are just two here for simplicity, and it is the marital status and the age of a person. So I'm going to create an anonymization hierarchy for the age attribute. So I choose the attribute that I want Amnesia to help me create the hierarchy on. I'm saying that this is a continuous attribute, so you will create ranges and not just groups of semantically related data, and the attribute type is already known. So the first thing I'm going to tell is that Amnesia is, I want you to cut the domain of ages that exists in the data set in 5-year periods. So the step, the range size would be 5. I'm giving a name so we can reference it later. Amnesia has read the data and it proposes to me a domain that starts from children of age 5 to elders of age 74, which are the minimum and the maximum ages that it has found in the dataset. But I can create, let's say, more generic hierarchy starting from year 1 to year 8, even if these values do not exist. And then to create this tree, I want each node to have 2 children. That would mean that 5-year periods will be grouped to 10-year and then to 20-year and so on. And now it has created this hierarchy for me. So in the lowest leaf, it has 5-year periods, 10-year periods, 20-year, 40-year, and then has grouped everything to ages 1 to 8. And the algorithm will try to see if this works. If this does not work, then it will start going up in the hierarchy till it finds a replacement of generalized values that adheres to the privacy guarantees we have imposed on the dataset. And now we go to the algorithm application, and basically what we have to do here is tell the algorithm which of the attributes can act as quasi-identifiers, and we tell them this by assigning generalization hierarchy to some of the quasi-identifiers that exist on the dataset. I will assume here that it's only marital status and age, and I will tie them to the generalization hierarchies we already created. And it also needs a parameter for k, how big will be the groups that will be created. So I will create a 2 anonymous dataset. This is the, let's say, lowest threshold I can put on the anonymization guarantee. It's the smallest size of group because this is a small dataset and I want to have some meaningful example. And I will just say execute, and it will create for me this strange graph. Now, what does this graph mean? What the algorithm does is it has now two class identifiers, like marital status and age. It will try to generalize marital status 1, make everything be single or married, and leave the age as the original. This would represent a solution that's represented by 1 and 0. One class identifier is generalized once and the other none. If the solution is okay, it is able to guarantee true anonymity, then it will paint it blue. If not, it will paint it red. So this solution will lose some accuracy to marital status. This is not a solution, right? It loses some accuracy on marital status and leaves age not generalized, but it doesn't solve the problem. The first solutions come here, and you have 3 different solutions that you can choose from depending on whether age or marital status are more important to you. So this solution practically destroys the information in marital status. It has anonymized it twice, and so it's completely removed, but it has preserved the exact ages of the original dataset, and it guarantees that if you know the marital status and the age of a person, there will be at least 2 persons in the dataset that share this information. This is a more balanced solution. It has grouped the marital status to single and married, and it has transformed the exact ages to 5-year periods. And this has preserved the original answer to marital status, but it has lost more information on the age attribute, and it has it in 10-year periods. Now, Amnesia also offers some more flexibility. If you double-click one of these nodes, you just apply the solution, but you can actually choose a solution that doesn't provide the guarantee that you want, and check the statistics of this dataset with the marital solution. And it tells you that, if I lose some information on the marital status and doesn't lose everything in the age attribute, then actually I can put 97% of the dataset in groups of size 2, and it's only 3% of the records that do not fit in such a group. So I might prefer, if I want to preserve more information, to just delete this 3% of the records that break my guarantee, and then have this solution that has preserved the exact age, but it has deleted a few records, the ones that appear as yellow here on the anonymized dataset. When you save the data, they won't be saved at all, so they will be removed from the data. And in this way, we have lost some accuracy on the marital status, which is not important here, but we have preserved the exact age to find the anonymization solution. And this concludes also the demo, so I'm open to questions.
Thank you, Manolis, and for your presentation. I have here 2 questions from Pierre Giorgio Basile. Let us say I have applied anonymization techniques, whatever they are, to my clinical data set. Is there a way to validate my data set is actually anonymized? Or does Amnesia validate whether or not your data set is anonymized? Maybe anonymization is not just a yes or no question, but there might be a score in percentage on how much your data set is actually anonymized. Thank you. And there's another one from the same person saying, using a data set that includes genetic data of human subjects, is there some extra attention requirement that should be considered for anonymization? Thank you.
Okay, as far as the first question is concerned, what anonymized means, the GDPR actually leaves it to the one that's applying it. It does not prescribe some kind of specific method. It just says that anonymous data should be transformed in a way that the transformation is reversible and you cannot single out some person. So it is up to the one who is doing the anonymization to really document this and explain why the transformation actually provides anonymization. Now, what Amnesia does and what all anonymization processes proposed in research is they make a mathematical interpretation of what anonymization is. And Amnesia does one here. It says, it adopts k-anonymity and says the data is anonymous if it is in a k-anonymous form with respect to quasi-identifiers. So all that Amnesia can do is tell you and guarantee that with respect to the quasi-identifiers you chose, all data are now k-anonymous, two anonymous in this case. You can use other, risk estimation methods that are different. You can compare this to, for example, general population distribution on ages and so on. But in a way, the result it gives you, it has a score, and the score is the anonymity guarantee. And here you get two anonymous data, which means that, let's say in a simplified interpretation, it means that if you know that a person is part of the data set that it's published, you have only 50% probability of guessing the right record. And if you put for anonymity, you have 24 probability for guessing the right record, even if you have background information in it. So this is the score that you get in formal anonymization guarantees. It is the guarantee itself, it is a score, and it guarantees you that all data are over a threshold, which if you say 2 anonymity, the threshold is 2. Now for the second question about medical data, from the mathematical point of view of Amnesia, it doesn't change something. GDPR says that data relating to health, political and religious preferences and some other categories or data related to children are sensitive data, and you need to have extra additional protection features. So maybe what you would do is, if the data were, if you want to anonymize data that have some kind of not so revealing property, like let's say people who own cars, you use k-anonymity with k equal to 3, and when you use you anonymize data that are health related and you want a strict guarantee, you use k-anonymity with k equal to 10. So the strength of the guarantee becomes stronger when you use when you apply it to medical data. And this is something that is a way to differentiate the additional protection that must be added to sensitive personal data according to GDPR.
Okay, I don't know if we have more questions to Manolis. Someone wants to, if you want to raise your hand and ask directly to Manolis, feel free to do it. If not, I would like to. So one of the limitations, what are the current technical limitations that you see in Amnesia, and what improvements are planned to be or desired for future releases, Manolis?
Well, the limitations we see at the moment are not that much technical, or they're mostly limitations on, let's say, in practice, that we don't know what parameters or what is, there's not enough practice out there in applying anonymization that we know the best parameters, or that we know the best guarantees. What we're pushing mostly in Amnesia is making making it more user-friendly and easier to apply in different types of data. That's why, for example, we're focusing on DICOM. We're not going to provide a different guarantee. We're going to stay with K and K anonymity for DICOM, but we're going to make it simpler for a user to apply this on records that can have potentially thousands of descriptive fields. I think one of the biggest challenges in practice is that real-world data usually have a lot more descriptive fields than the examples we use in research, right? You see the research paper, you see the proposed methods, and they assume that we have 3 descriptive fields for millions of people. And then you go to practice and you have hundreds of descriptive fields for thousands of people, which makes the problem a lot harder. So our future direction is trying to improve the applicability of anonymization methods to real-world data. And this is our focus in Amnesia.
Okay. Just one last question. There's a question here. Vitor Basto Fernandes. Who, researchers, data stewards, other specific professional is Amnesia designed to be used by? What kind of profile or expertise should they have, and what kind of training they need? Okay. It's a little bit related with the question I was going to make you also, is how do you see research teams integrating Amnesia into their data management workflows? So from planning to publication of anonymized data sets. So in here we see all the roles and what capacity they would need to use this tool and to integrate this tool into research management.
Thank you for your question. We would like Amnesia to have the broader, user base that it can. It has to be able to be used by researchers, data stewards, and also from the people who do the operational work that collect the data, which might not be researchers, right? It might be a bank IT department that collects the data and then wants to share the anonymized version for marketing analysis with a third party. And even in researchers, IT researchers were more related to more familiar with anonymization methods. So of course, it's easier to them, but we would like any type of researcher to be able to use it. So our focus is to lower the technical barrier and make and allow everyone to use this. So in my mind, at this moment, you need to have 2 skills. One is to be a kind of experienced user of IT products, right, like Excel. This does not make you a researcher, but to understand what is a comma delimited file, to understand how data are presented in a table. And the other one is you need to understand the basics of anonymization, because as you saw, it's not just a process of one button, load the data, press the anonymized button, get the anonymized data. You need to understand a bit what information you're losing and what you're preserving. And this is expertise on the domain and not so much expertise on anonymization. You just need to be able to understand the basics. And this is why, for example, I did the presentation with a theoretical background before presenting Amnesia.
Thank you. Eugenia is asking, Amnesia is free?
Yes, it is free, and it is free for any type of use, from academic to commercial.
Yeah. Okay. So I don't see more questions. So we are on top of the hour. And if there's no more questions, I would like to once more thank you. Thank you, Manolis. So if you want to put your, I also shared here the link for the help desk for, I don't know if it is operational, but I'm assuming yes, but it goes to the help desk service of, I'm going to place it here in for open air, right?
Yeah.
Goes to the help desk, okay. So if there's people here who wants to know more and to try to get in touch with Amnesia support service, so they could address some questions using the help desk service. So thanks again for being here, for all being here. Although we are the country is on strike, so fighting for labor rights. So, but even so, we had quite some people here in the audience. So I would like to thanks again, and to you, Manolis. Thank you so much for being with us, and to clarify how to use Amnesia tool for our researchers and for our community. So thank you so much.
Thank you very much for the invitation. It was a pleasure seeing you again, and a pleasure to giving this webinar. And everyone, please feel free to contact me either personally or through the help desk.
Okay, thank you. Thank you so much, and goodbye.
Bye-bye.
Thank you. Yes, goodbye.